Okay, today's video is about hybrid electric vehicle training. What I'm going to do today is show you some of the solutions that are out there in order to bring over the complexity of these high voltage systems, but also to do that in a safe manner. So reducing the liabilities for the teachers and the schools out there. While the end point is to be able to fix and repair these high voltage vehicles, we're going to need some different options to get the students up to that level. And so that's what I'm going to show you today with our new CarTrain systems from Lucas Nula. Okay, so these are the two systems that I'm going to show you today for high voltage training. So first of all, we've got the truck train system here looking at heavy vehicle high voltage systems, plus also the CarTrain system for looking at light vehicle high voltage systems. So this is our solution for trying to understand how high voltage systems work, but also doing it in a safe manner. So if we have a look here, we're able to have a look at the various types of modes. For example, here we've got 5 different types of hybrid and electric vehicles that we can show within this system. And that's simply a matter of changing the overlay mask that we see here . We can simulate different types of vehicles. And in this instance, we've got a Toyota Prius that we're showing here on the interactive display. Okay, so we can start the system like normal and have a look as the system boots up, going through a preload phase as it would in a real vehicle. Once we're in ready mode, we can drive the vehicle and have a look at the energy flows that's very hard to see on a real vehicle. So for example, driving the vehicle through different driving strategies, uphill, downhill, and in regeneration mode, we can quite easily see the different types of energy flows that you'll see on a real vehicle. We can also, going through our e-learning software, LabSoft, we can start to do many experiments that are related to the different types of training needed around the world for high voltage vehicles. So going from the different types of vehicles, why we have electric vehicles, to different types of electric vehicles, how to identify electric vehicles. We go right through into how the electric vehicles work also. We also have an overview of the experiments that are available on the system. We can see here there's over 40 experiments, including diagnostic tasks that we can do on this system. Okay, of the various experiments that you can do, we can go in here and see what some of the real life voltages are that you would see on a real vehicle. So here's an example of the experiments and how you would do the experiments. Step-by-step guide is showing the students how they can undertake the experiment. So there's no need for the teacher to be there at all times. Okay, so from here we can plug up our measuring devices, call up the measuring device, and we can see here that we're at 305 volts, so seeing the real high voltage that you would on a vehicle. Some of the other experiments that we can do here, we can also have a look at how the 3-phase motors work in an electric vehicle. So going down to another chapter within the e-learning, we can see the theory behind how a 3-phase motor works. So for example, 1-phase, 2-phase, 3 phases, and we can see how a magnetic field is being produced through a coil. And then on the 3rd phase, we can see how a rotating magnetic field, which allows that motor to turn, basically the rotor within the motor. Okay, so we can see how that's done in theory, but we can also see how it's done in practice as well. So again, pre-prepared experiment. How can we do that? This time we're using an oscilloscope. Change to the appropriate settings. Oops. And there we can quite easily see how a three-phase motor is being driven by an inverter on a modern vehicle. What we can also show on the vehicle is how to perform diagnostic procedures and fault finding on high voltage vehicles. You can see here we've got an integrated fault switches with 7 different faults ranging from motor faults, battery faults, inverter and insulation faults. So simply clicking on here, I've put in an example on what to show for insulation fault. You can see now we've got a yellow fault within the system. Okay, so now once we've got the fault within the system, we can go into the integrated scan tool and it gives us here a real fault code, P309, high voltage leak to ground on one of the motor generators. So now we have to see which one of the motor generators has the fault. So what we're going to do in this situation now is to show the students how to perform an insulation test. But in order to do that first, they need to do an isolation procedure. So in this case, we have all of our safety equipment ready. So for example, wearing glasses. We also have our safety lockout box and padlock here. And also our gloves. So high voltage gloves. In this case, we're going to use leather over gloves as well. There's a number of things that we need to test first with our gloves is to make sure that they're first of all in good condition, which these ones look like they are. We also need to make sure that the date is within date. So when was the last time they were tested? And we fall within 6 months there, so these are okay to use. Plus we also need to do a test to make sure that they don't have any obvious holes in them. So test them, make sure we can't hear or feel anything. That one seems okay. And the same on this side as well. So our gloves are fine. Okay, what we need to do from there is take the ignition key and put that inside of our box. And disconnect the 12-volt system. And we also need our measuring device. So in this case, we need a category 3 rated multimeter so that we can measure the high voltage. And we're also going to use this one because it's an insulation tester at the same time. So one of the first things I need to do is make sure that our measuring device is working. So in this case, I want to go along and measure our 12-volt battery. So we need to make sure that our measuring device is actually working. So I'm testing that on the 12-volt battery here, and we can see that we've got 12 volts at the measuring device. So that's telling me that this guy is working. So I'll put that down to the side here. Now this is when I put on my gloves with the over gloves on top. And I'm going to remove the service disconnect here now. And now we put the service plug also into the safety lockout box, and we can lock that box away to make sure that no one else can start this vehicle while we're working on it. The key then belongs on my body so that no one else has access to that box now. Okay, so the vehicle has now, 12-volt system has been isolated, and we've also removed the service plug. And now we remove the cover for the measuring point so that we can measure to see if the high voltage has dissipated. I'm also going to do this one-handed. That's showing that the system has now gone down to 0 volts, which is safe, but we want to make sure that our measuring device is still okay. So I'm going to come back to the 12-volt battery to double check that we still have 12 volts. Okay, now that we've made sure that the vehicle is safe to work on, we can do the insulation testing. Okay, so we can use the same measuring device, but we need to switch around how the leads are and then change the settings. So using the breakout box up here, it's quite easy to take some measurements. We've got our ground point right here. And because we don't know exactly which motor generator has the fault, we're going to start on motor generator 1. So simply by doing the insulation test. We can see here 550 mega ohms. That's done at 500 volts, so it's actually doing a real insulation test. We can see with this result right here that motor generator 1 is perfect. So we'll go to motor generator 2 now. And you can see in this case 0.3 mega ohms, that's well under the limit for a correct insulation test. So we can see now that the fault lies within motor generator 2. Of course, the student would go through this on the LabSoft course, performing their diagnostics and recording their results. At this point, when the student's finished, the teacher could come along and then switch off the fault, and the student would put the system back together, making sure that the system is then running as it would need to be. Okay, so what you've just seen here is a very short overview of what the system can do. There's of course many hours of learning, covering all of the basics required for a lot of the qualifications around the world. And what you see here with the light vehicle CarTrain is pretty much exactly the same as what you'll find in the truck train system, but this one of course is then more aligned to the heavy vehicle aspects of high voltage. So thanks very much for your time. Hope that answers some of your questions about how you might be able to now train safely on hybrid and electric vehicles at high voltage and make that connection between the real vehicle and what needs to be done on the training level. Thank you.